So hey guys, welcome back to my channel. Hope we are doing extremely well, and this is your very own mask code at this side. So in this video we are going to discuss the problem rotate a linked list, and it is a very simple problem if you will stay with me. Now the problem says that you have been given a linked list. You can see the linked list mentioned here. This is obviously the head of the linked list. You have been given an integer k, right? And what does this k signify? K signifies that you have to rotate a linked list clockwise k number of times. You have to rotate the linked list clockwise k number of times. That is, you have to rotate once, then twice, then thrice, right? So after rotating this linked list once, what will happen? Clockwise, right? Clockwise. What is clockwise? This direction, right? What will happen? One will go to the end, and it will do something like 2, 3, 4, 5, 1. Again rotating, so 2 will go to the end. That is 3, 4, 5, 1. Again rotating, that is 3 will also go, so 4, it will be 2 here, sorry. 4, 5, 1, 2, now 3. So this is the final English. This is your answer. That is 4, 5, 1, 2, 3. Now the problem is how to reach it. Problem is how to reach this answer. So brute force is really simple. Brute force is the algorithm we just used. That is while k minus minus, first decrement your k, right? Now what will you do? Well, k is not equal to 0, that means like k number of times rotate it. That is how it will how will you do? This is your head, right? You can see the new head is this one, right? This is your tail, right? Then attach this head to the tail, that is up till k, right? Attach this head to the tail, that is this connection will break, this connection will form, and this will remove from here, and your new head will become your original head now, and new head will, in the next iteration, new head will be this, something like that, right? And tail will be this in the second iteration, right? So you have to change. So what will you do? You will say, suppose you have already taken tail in your hand by doing something like this. You kept your tail here and you traverse the linked list until tails next was not null. You will reach tail here, right? Okay, then you have your tail, you have your head in a hand, right? Now what will you do? It is really simple. New head equals to head next, right? New head equals to head next. uh, Head next will now become null. That is, I break this connection. Tails next will now be head. Tail next equals to head. That is, this connection is formed. After that, new tail is actually my the connected component. That is, tail equals to tail next, and new head head equals to new head, which was assigned earlier, right? As soon as this while loop finishes, return your head, return head, return head. Now, you can see that this algorithm is working in O of n complexity, and the space complexity is O of 1, because you are not keeping any count or etc. storing somewhere, right? But it is not working in O of n, it is working in O of 2n. Why I am saying 2n? Because to find the tail of the node, you will require an O of n traversal again. So O of n here, O of n here. So it is O of 2n, which is essentially O of n, but I want to do it in exactly O of n. I don't want to spend any more time than O of n. Then is it possible? Then is it possible? It might be possible. Let us see. Okay, so the given linked list was 1 connected to 2, connected to 3, connected to 4, connected to 5. This was my given linked list. I was given k as 3, and my answer came out to be 4 connected to 5, connected to 1, connected to 2, connected to 3, right? Means if you see now how to solve the linked list problem, you just see that what is the new head. First problem is what is the new head. That means what is the new head after doing all the calculation? What is the new head after the answer has been in my hands, right? So you will see this node actually becomes the new head. Question is how many traversals, how many jumps from the head to reach new head, right? So if you see, it will require, if you're standing here with temp, this is my head of course, and if you are standing here with temp, it will require one jump. After that, second jump, After that, third jump. That is k number of jumps are required. K number of jumps are required. Also, I forgot to mention in the question it is mentioned that k is less than equals to n, where n is the length of the linked list, right? N is the length of the linked list. I hope I am clear, right? Now, once you realize that this is gonna be my new head, that is after k jumps, what can you do? It is really simple, right? It is really simple. I am doing something like this. I am saying my temp is equals to here, my temp is here, my tail is here, my previous is at null, right? For k number of times, that is 3 jumps, I will do t equals to t next and previous equals to temp. That is previous will come here, temp will come here, previous will come here, temp will come here, previous will come here. As soon as temp comes here, the loop finishes and I will say new head equals to temp, right? And now I will break this connection. Previous next equals to null, right? This connection is broken off. Let me rub the connection, right? Now I have got this part. If you see 4 5 is as it is. If I have said that this is my new head, 4 5 is as it is, I just have to connect this thing, that 5, with this one, right? Because 5 is my tail. My tail is still kept here. What can I do? I can say tail equals to new head. Right now I will assign my tail here and I will traverse forward and I will say while tail next, tail equals to tail next, tail equals to tail next, right? Tail equals to tail next. Now tail will come here and iteration will broke, right? Now I have my tail here, I have my head here. I will say tail next is equals to head, tail next equals to head. And now if you see, this 5 is getting connected to this one and exactly this answer linked list is forming. That is 4 5 1 2 3 and that is my answer. And I will just say return your new head, return new head, return new head. So if you see, evidently O of n is required because I'm traversing the linked list only once and I'm carrying the operations mid of it. Now there is an edge case here. What happens if k equals to 5, that is k equals to n? So my temp is here, first jump temp will come here, second jump temp will come here, third jump, fourth jump, fifth jump, and the iteration will stop and I am actually at null node. And if you see, evidently for the k equals to 5, let me write it down, right? So 1 2 3 4 5, we figured out that for k equals to 3 it was 4 5 1 2 3. Then for k equals to 4, what will happen? 5 1 2 3 4. For k equals to 5, what will happen? 1 2 3 4 5. And if you can see, it is exactly equal. That is when k equals to n, configuration is same, configuration is same. So when k equals to n, my new head, my temp value will come at null. So I can, before doing my tail etc, I can just say here that if my new head equals to null, return your original head. Don't do anything. Don't break any connection or form new connections, right? Return head. That's all, right? This is your actual code. What is happening? First, we got to the new head by doing k number of jumps. Then we got to the tail by going forward, and then we connected tail to the original head, and we then returned the new head. This is the only thing that is happening, right? O of n is time complexity, O of 1 is the space complexity, and it is time for you to see the code for it. You can see the coding section, guys, in front of you. Before starting with it, I would like to request you to please subscribe to the channel because it really means a lot to me, right? Moving forward, what will happen? First, I will make a node star previous equals to null. Then I will make a star tail equals to null, right? Then I will make a star new head equals to head, right? And now while k, like I can just use a for loop as well. For int I equals to 0, I less than ki plus plus, it will run exactly k number of times. What will happen? First I will assign previous the new head before traversing. I will traverse the new head equals to new head next, right? Now what will happen? I will just do the simple thing of, I will just say previous, if I will check, first I will check if new head equals to null, return your original head, return head. Now previous next is gonna become null, and now I will say tail equals to new head, and now while my tail next is not null, tail equals to tail next, tail equals to tail next, that is return, go to the last node of it. After you reach the last node, tail next is now gonna become head, and now you can simply return your new head, because that's what you need, right? Let us try to compile and run it. Hope it will work fine. It is working fine for the sample test case. Let us try it for the submission test cases as well. Working fine. So thank you for watching. You can see the 229 day streak. Hope you're loving my streak and keep supporting. Thank you. Have a nice day.